Okay, so I'd recommend using the short link, that one. It's okay. It's fine. Nice of you to share it. I do appreciate it. It's always very helpful to have people trying to help me. So thank you, Emily. Today I'd just like to do a bit of a Q&A lecture and go over a little bit of the logistics about the next kind of phase of the course. And yeah, just talk a little bit at a high level about what you're going to see in the assessment. And I'm going to show you briefly the actual data that I'm intending to use. So it should be good to go here. As we're going, feel free to submit questions in the anonymous Q&A that I've sent, or just do it in the chat. I know that sometimes students feel a little awkward submitting questions, especially ones that they kind of feel are silly or frivolous, under their own name. So you're always welcome to join the lecture, I think, under a different name, but then I think also you can, you can use this anonymous Q&A that I've put there, and we'll go ahead. So I'll just keep that anonymous Q&A running the whole time. I can see it as I'm presenting, so I'll try and answer them either there or in the real chat. But just appreciate that my attention will be divided in the purpose of giving you some anonymity. So on the logistics, my understanding of the final is that there's going to be a so my understanding of the final is that there's going to be a post on Blackboard that contains the final at 10 a.m. GMT on Thursday. Now, the final is about as long as one of the assessments. I have made sure to break out the individual components of interpretation so that you're not going to miss anything that I'm expecting. So some students have kind of said that they're not sure how much to write on any given question and things like that. So I'm not going to show you the exact final. I'll show you the top of it so you can see what the data looks like and stuff. But I'm going down to like 4.1.1 kind of thing. So to show you a little bit more what I'm talking about here, I might have like text that says, to estimate a relationship that's not how you spell relationship. Estimate a relationship between price and earnings. And then I'll say from this model, and then maybe say 2.1, what's the significance of the effective price on earnings? And then if I'm expecting you to make like sort of, great, Geography Office has just emailed to confirm the 10 a.m. schedule on Thursday. That's probably because I just sent them the document. It's been through 2 rounds of moderation, I should say. So plenty of people have reviewed this to make sure that normal human beings can understand what I'm writing. So I've tried really hard to make sure that it's really clear and straightforward. So if I have something like this where I'm saying, what's the significance of the effect on price on earnings? And I might be expecting you to compare it back to something else. I might say 2.1.1, compare this back to your previous model in section 1. So I've tried to be really clear when it's individual components like that. Or like another thing that might happen is, you'll have like from this model, and then I might have, this might be 2.2. Then I might say 2.2.1 is the effect section 1. I'm never referring to previous assignments. I'll only be referring within the assessment. So I might have something like, is the effect of price significant? And then I might ask, is the effect of gender significant? So every time I'm asking you to do an interpretation, I'm trying to be really clear that, it's going to be one discrete thing for every point. So there's going to be sort of less leeway to kind of miss the point of a question, I think. So I'm trying to get really secure so that you're able to really hone in on this. Question in the chat, is it that questions will draw from different parts of the course, or each question will draw on multiple parts of the course? The questions will draw on multiple parts of the course, but it's not going to be the exact same questions you've seen before. So they will be, like, there will be one question with a linear model, there will be one question with a logistic model, and there will be one question with a multi-level model. And you'll use them to tell me different things. There's not going to be a multi-level logit, because that one was pretty hard for people. So there's going to be one of each of the kinds of models we've talked about in the course. There's going to be some visualization and some tidying at the beginning. So like I said, I write these things in kind of the same format every time. So it's some exploration, maybe a first or second model, and then another model. It's supposed to develop kind of across the whole thing. You're asking a single question. I'd like to show you that prompt now, if everybody's okay with that. So the prompt is this. Your friend from school has just returned from their gap year as a woofer in a small estate outside of Lyon. They claim that there's nothing quite like a French wine. They're better, more expensive, and they know it. But you have your doubts. So you, now a freshly minted data scientist, decide to moonlight as a data sommelier. You find a nice data set of all the wine ratings you can find and get to work. The data set looks like this. Okay? So it's going to have the country where the wine is made. It's going to have the description or tasting notes of the wine. It's going to have the designation, the points, which is like the rating that's given by the sommelier to the wine. It's going to have the price in dollars per bottle of the wine. It's going to have the province, which is like, in the US it's a state, but in France it might be like Bordeaux. And then two smaller regions, which are going to be it goes province, then region 2. And then the variety is like the kind of wine or grapes. And then the winery is where it was, like who grew it. So there's like a little bit of text here that talks about what that is. And we're mainly going to be asking questions about the country, the points or the rating of the wine, the price, and the variety. Okay, so that's really what we're going to be focusing on. The country, the points, the price, and the variety. And if you think about this whole endeavor, the main point, I guess this is not a up-to-date version of this assessment, so there's a little bit different that I need to pull up. Sorry, let me do that real quick. Yes, here we go. Okay, so I'd just like to share this real quick because there's a little bit different of a thing. I made it more clear in this draft. Can everybody see this question? Are French wines really the best, or are they just more expensive for the same quality? That's going to be the question that you're going to return to over and over again throughout the assessment. So if there's something that you're doing in the assessment, its whole point is to try and shed empirical light on that question. Are French wines really the best, or are they just more expensive for the same quality? Are they just overpriced? Okay? So what I'm hoping for is that by making this really clear and really obvious about what the main point of the assessment is, it'll be easier for you to kind of hone in on the gist of a question, okay? So this is going to be the main point. Your overarching mission is to shed some light on this question. Are French wines really the best, or are they just more expensive for the same quality? Okay? So when I say, that there's this overarching question, that's what you should use to kind of structure your responses, just keep that really clear. I'm walking you through an analytical story that I hope at the end of the day you're going to tell that involves different models that talk about different traits of the wine data. And your whole goal is to think about, are French wines really the best? Are they really exceptional? Are they, very easy to pick apart from the rest of the kinds of wines? Or are they just more expensive for the same quality? So you'll get to tell me a little bit about that when you conduct a couple of models. And it's always structured in the same way that you've seen before assessments. It's going to be a little bit of exploration and plotting. So it's the whole assessments are always like this. Your section 1 is going to be exploration and plotting. Then 2, I'm going to ask a simple empirical question, maybe using a model. Okay. Then I'm going to ask you a more complicated empirical question. This will use a multi-level model. And then, finally, a generalized linear model to predict something. One of the anonymous questions is, will questions in each section effectively tell us which components to include in each model, or should we develop the model beyond the parameters given? If question only asks about the gender and price and earnings, just include these, or are we expected to use others in the data set to improve the model? Nope, you can just go immediately off of the specification I give you. So if I tell you to, say, predict the, let's say, predict the rating of a wine, or predict the points of wines, using country and region as the predictors, then you'll need to be just fitting that model and tell me a little bit about its structure. If I tell you, using a multi-level model, allow the relationship between, let's say, I don't know, age and price to vary by country, then you need to turn that into a statement of a model and ask that. You know, if I say, use a logistic model to predict whether or not a wine is a Bordeaux using its price and rating, then you'll need to do that. If I ask, you know, what is the average price of a wine in each of the countries, you'll need to know to use a group by. So it's going to be structured like that, right? So like think about assignment 1 and 2 as like the scaffold for this kind of thing. Now there's 1 or 2 questions where I ask you to make a visualization, and that's again, just make it really straightforward and simple. I do need a visualization for those, but if you want to like really aim for the high firsts, you might also think about visualizations to demonstrate your point in other sections, but those won't be expected of you. That means like you can get a 2-1 or a 2-2 if you just do what I ask you to do. And yeah, it's just going to be straightforward. It should be max a single sentence for many of these things. You fit the model, you tell me what it says. Now, there may be some questions where I say, you know, give me a grounded interpretation or think about what this means. And there, that's going to be much longer. We'll have a lab for, not much longer, but that'll be a little bit more, you know, 4 sentences. We'll have a lab on Thursday that'll go over exactly where this happens. And I can give you answers to questions about clarification of the text, but nobody's going to give you any hint as to what code or what other kinds of stuff you're going to use. So this is training wheels off, using all of the stuff you've learned so far, try and answer the questions. Okay? Anonymous asks, will you suggest what plots to use in the assignment? Well, if I ask you to say, show me the distribution of X, then you need to show a distributional plot using something like the data from Viz suggestions. If I ask you, show me the relationship between, I don't know, price and rating, you'll need to do that using stuff that we've talked about from data from Viz. So I'm going to ask you to show me a specific concept, and I'm not going to tell you make a box plot of X or make a scatter plot of Y. In one case, I will also ask, what visual technique is used to compare these models? Or what visual kind of method am I showing you in this plot? I'll give you a plot, and I'll ask you to describe the plot. So it shouldn't be that complicated. You should immediately recognize what's going on with the plot. And it's just to show that you sort of understand the different kinds of visualizations we've been talking about and some of the different tools that we taught in the visualization block. Anonymous asks, we are not using a logit model. I said that we were not using a multi-level logit model. There will be one logit, there will be one multi-level, there will be one question you can answer using a standard linear model or just a simpler test than that. And then there's going to be like group bys and plot. So it's going to be those 4 chunks, kind of like assignment 2. Okay? So with that said, that is kind of the logistics of the exam. Does anybody have any other questions at a high level about what will be expected of you? Some of the sections will only have 1 point, and you'll be able to get, if you know kind of how to interpret the model, you'll go right through it. I, in particular, anticipate section 2 and section 1 to be pretty quick. You'll recognize the pattern, you'll do it, and you'll be done. There are challenge questions, I think, in section 1, 3, and 4. Feel free to do those if you can. They are not code heavy in many cases. The challenge question in section 3 is much more about real world interpretation and using the revelations from sections 1 and 2 to inform your thinking. So it's much more about can you reason with these models than it is about getting really complicated with the programming. So there won't be any significant kind of programming expected, except for maybe question 4 in the challenge. So it's going to run the whole range of things. People that aren't very good at the code but have a good conceptual understanding should be able to complete this assessment just fine. And people that are really whiz-bang at the code but maybe aren't as good at telling me what that means, there will also be an opportunity for you to demonstrate your excellence. So I've tried to make sure that it covers all the bases, and it definitely hits every single thing we've talked about in the course, except for maybe heteroscedasticity. So yeah, it's hitting all of the main points of the learning outcomes of the course. I don't see any other questions popping up in the chat. If there aren't any further questions, I might move to just doing a quick review lecture of how to think about multi-level models and logit models. Unless there are other things that people want to ask about. I'll give 2 minutes, I guess, fully to kind of catch up and write questions if you have them. I should say, if you are out of country or planning on sort of having internet issues or things like that and want to download the data early, or you're going to have some issues downloading the data on Thursday, please let me know, because I can get you the data sooner than later. So it's going to be hosted on my website, the data, and you should be able to access it as it's released. So no other questions I'm seeing. When will we go over the last assignment? I have to do that after the hand-in because I've been told that there are too many students who have not yet submitted, so it needs to get reviewed. Sorry, what I mean is it needs to get submitted by all students before I'm able to do that. So I'm not going to be able to do that until Thursday. Someone asks, could you please also go over GLMs? Well, we're only talking about logistic models. So I'm not going to introduce like new material as far as like Poisson regressions or negative binomial regressions. But I'm happy to revisit the logistic model, which is a kind of GLM. I'll do that in the second half. Anonymous asks, will we still have practical on Friday? Yes, I will be talking about the answers to the visualization assessment. You are not expected to attend. The answer session for the visualization assessment is going to be pretty straightforward, and then you're also able to use that as time to ask clarification questions to the text of the assignment. But as I said before, nobody will be providing code assistance on this stuff or conceptual kind of hints like we have in the past. You need to, this is just a straight up kind of deadlift on your own back, basically. You've got to got to do it from the stuff you've been prepared for and the stuff that you've succeeded on in the past. I have faith that everybody's going to do well on this, just like everybody has been doing well throughout the course. My mark profile has been, I've heard, suspiciously high. So I have faith that you'll do well, and I'm sure it'll be okay. Give yourself plenty of time. Okay. Will I be answering the forum questions over the assignment? I'll try to, yeah. It'll be good. Will we get the visualization next term? Yeah, probably. I'm not going to be able to mark it in time. Yeah, on the forum questions, I don't know why, but my email has started sort of flagging those as spam, no matter how many times I say it, they're actually not spam. So I miss them sometimes, and I've tried to kind of make sure that I attend to them every Monday, but I've been quite busy recently, so I've just not been able to get to them as I've meant to. So I'm really sorry about that, and I fully plan on making sure that all of the questions that are asked in the discussion board are addressed by the time the final is dropped. So, okay, so with that, now we're going to start the second half of the lecture, unless there are any further questions. Not really seeing any. So let's go to a little bit of multi-level models. And then we'll also talk a little bit about GLMs. So the main purpose of multi-level models is to allow parameters to change depending on the groups. So earlier in the course, we had an example of the relationship between earnings among men and women in a social survey in the US. And so to kind of think about stuff like that, let's say we have the relationship between, I don't know, let's say, let's say cookies and presents that Santa brings. Okay? And let's say if you're a good kid, that if you leave out more cookies for Santa, you get more presents. But if you're a naughty kid, let's say the more cookies you leave out, you get a negative slope. And if we were to try and fit a line of best fit, you might get some really strange results. You might get something like this. You might get something like this. It just depends. The issue here is that the variable naughty and nice is confounding the relationship between cookies and presents. If I try and fit the overall line of best fit, it might show me nothing. It might show me something that's obviously wrong. Way too steep of a relationship. So multi-level models allow the slopes and the intercepts to vary by group because of this phenomenon. Okay? Now we've talked about a couple of different types of multi-level models. We've talked about multi-level models where you have varying intercepts. We've talked about multi-level models where you only have varying slopes. And we've talked about multi-level models where both of these happen. Okay, so this is the varying intercept. This is the varying slope. And this is the varying slope, varying intercept model. Okay? So we will have these 3 different kinds of models, and you can always have more than that entailed in a multi-level model. You can have multiple different slopes that all vary and things like that. So focusing in again on this kind of concept, a multi-level model says that, you know, the number of presents that a child on Christmas receives is a function of the slope for that group, J, and then the number of cookies that are left by the fire, plus the baseline for that group, plus an error term for the number of presents. And what a multi-level model does is it splits up these terms into parts. It says, okay, my relationship between cookies and presents is a function of some global effect plus a group level error term. And likewise, my intercept for each observation is going to be equal to some global term and some error for that group. Substituting those back in, we get the classic statement of the fixed effect model, or the mixed effect model, which is B plus Wj times the number of cookies at the fireside plus A plus Uj, which is the constant, and the error term. In terms of the language of LMER, how you fit it, this and this are the fixed effects. They describe the overall estimated relationship regardless of the group that you're in. These are called the random effects, and they indicate the deviation from the overall relationship or overall estimate. Okay? So when we're talking about the overall, we're talking about fixed effects. When we're talking about the group level deviation, we're talking about the random effects. A multi-level model is a model that places this kind of secondary model on its parameters. So I've got a second model for each of the parameters. So it's actually 3 models overall. Okay? So that's the main concept of the multi-level model. Now in contrast, I might have a different kind of prediction problem where I have a bunch of, I don't know, people that are considered nice kids and a bunch of people that are considered naughty kids. And the naughty kids might be represented by 0, and the nice kids are represented by 1s. And the underlying kind of variable here might be, I don't know, bribe money in dollars. And this is going to be is good. And so if you're in the green group, you're a good kid. And if you're in the red group, you're a naughty kid, like I used to be a lot. And the relationship between the two is just binary. Either you're 1 or you're 0. One of the models that we've talked about before is the linear probability model. Which just fits a straight line between the two groups. The issue with the linear probability model is that we get probabilities that are predicted greater than 1 or less than 0. So the line represents the predicted probability of a kid being good, depending on how much money they bribe Santa with. In order for them to be real probabilities, they have to fall somewhere between 0 and 1. In this example, they don't. You've seen this as well in the workbook. So the linear probability model is just a linear regression on a binary outcome. Now, the other thing that we can do is fit a generalized linear model like a logistic regression. The logistic regression is a linear regression on the log odds of y. So if we observe some value y for every observation, that can be either 0 if naughty, or 1 if nice. Wait, I'm using green. Then I introduce some kind of implicit thing that we don't actually see, which is pi, which falls between 0 and 1, which is defined as the probability a person is nice, and I say that I'm modeling the log odds, which is the log of p divided by 1 minus p, using a linear regression. if I use this model, then I get an S curve that goes up and then stops at 1 and goes off into infinity. So what this means is that as our bribe money gets bigger and bigger and bigger, the probability that a student is actually considered, or a child is actually considered to be a nice kid, increases. Likewise, as our bribe money decreases, the probability the kid's naughty increases. But it does so in a nonlinear fashion. We're representing it as the log odds. Now, there's a question in the chat saying, would you be able to explain the difference between a multi-level model and a generalized multi-level model? The generalized model of any kind, Poisson, negative binomial, logistic, like what I'm showing you here, the main point is about where the linear part of it is and what it's in terms of. So we call a logistic regression because the logistic function maps us from what we model in the linear term, this log odds, back to y. Once we're in the log odds, it's just a linear model. So the point of these kinds of models is, okay, I have a y that's really not normal. In this case, it's binary. Either a kid is naughty or they're nice. And I can't assume that my residuals are going to be normally distributed if I model it directly there. So instead, I'm going to introduce a different sort of function that maps me from something that is linear, where I can do linear regression, and my original output, which is just binary. So a multi-level model is a model where you have parameters for each part in your model. And the reason why we call multi-level models multi-level generally is because they have some kind of error term in each part. So it's like a stochastic, as we say, or a random component to every part of that model. In a generalized linear model, there's no error term. So you see that there's just one error at the end of our transformations. There's not an error term here, and there's not an error term here. If it were a multi-level model, every transformation or every kind of step would have its own error term. So a generalized multi-level model, like you fit in one of the assessments, would have a J term here, which allowed the slope and the intercept to vary by group. And when you retranslate that back to the space of the logistic curve, it might mean that one of your curves looks like this. Maybe another curve looks like this. Maybe another curve looks like this. But the differences in alpha and beta are just going to change the speed at which the curve goes up and the location where that kick starts. But the main point is that a generalized linear model is just about the transformations that take us from y to something that we can model using a linear model and then back. So the generalized linear model, or sorry, the multi-level model is about allowing your effects to vary by group. The generalized linear model is about what happens when y is not normal. You can mix them together, but we won't do that in the final. You've done it in an assessment. So it will either be a linear model, or it will be a multi-level model, or it will be a generalized linear model. In this case, the only one we've talked about, the logit. Okay? Someone asks, could you please go over how to write this in R? Yeah, sure. So the logistic regression is fit using GLM. And in this example, what was it? Is good is a function of bribe money data equals Xmas family is equal to binomial. And those are open and closed parentheses. Okay? So if I'm fitting these multi-level, or if I'm fitting this one single generalized linear model here, this is the term, or the equation. After that binomial, those are open and closed parentheses. So that's like open and closed parens. You can also use quote binomial, and that should also work. Maybe that's easier to see in this. Yeah, I know. It's tough. So you can use the quote binomial. In our other model of cookies and presents, the R code would look like, let me just move these over a little bit. The R code would look like LMER, cookies, or no, sorry. The Y is the number of presents, is a function of, I'm not going to have enough space here, sorry, hold on. So it's going to be the number of presents is a function of 1 plus the cookies plus the random terms, 1 plus cookies which vary by is nice. So using our terms from before, this is the random, and that is the fixed. And then you're going to have data is equal to Xmas. Okay? So that's the varying intercept, varying slope form. If you just wanted to vary the intercept, you keep cookies out of the grouping factor. If you just want to vary the slope, you keep the 1 out of the grouping factor, or even better, you add a 0 in the grouping factor instead of 1. But that's the multi-level, and that is the logistic. Okay, so naughty or nice, logistic. Varying relationships between cookies and presents, multi-level. Patrick asks, is the grouping factor in green? The grouping factor is this term here. Great question. We're allowing the slopes to vary depending on whether or not you are naughty or nice. So one group is the nice, and the other group is the naughty. So our grouping factor comes after the pipe. Does that make sense? The grouping factor comes second in that. It's the random effect by group. The grouping factor is nice. It is not cookies. Because you wouldn't group the kids by the numbers of cookies they give. You'd group them by whether or not they were naughty in order to create a separate line for being nice or being naughty. Yeah, I can do that, Patrick. So, varying intercept would be 1 plus cookies plus 1 by is nice. So that's going to be kind of hard to write in this space. So that would be 1 plus cookies plus 1 by is nice. That's varying intercept. Okay? Varying slope would be 1 plus cookies plus 0, because I'm saying, damn it, don't vary the intercept, plus cookies by is nice. So I've got just a 1 in the grouping factor for the varying intercept, and I've got 0 plus cookies for the varying slope. For both, I use both in the grouping term. 1 plus cookies plus 1 plus cookies by is nice. Those are the 3 specifications. We would use the varying intercept when we expect the relationship between x and y to be the same over groups, but those groups should have different baselines. This is kind of like the instance where we were talking about sex and earnings. We would use a varying slope model when we would expect everybody to have the same baseline, but a different effect of x on y. So one might think that if you're a good kid, then giving Santa extra cookies might increase your amount of presents. If you're a naughty kid, giving Santa extra cookies won't really affect the number of presents you get, right? So it might look like this, where the naughty kids have the horizontal line and the nice kids have the vertical line, or the steep line. But all kids start off with, say, 2 presents. So even if you forget to give Santa cookies, you'd give him 2 presents. And then remember, nobody gives Santa no cookies, so you might have to center your cookie variable. Okay, so varying slope we use when we expect everybody to have the same baseline, but maybe different effects. And we use slope varying intercept when we would expect both of those things to change. Okay? Now they've got some more room. I might move this over. Cool. Okay. So that's what I have to show you today, is the multi-level modeling and the generalized linear modeling. I will post this online. And we'll be good to go. So I'm going to stop the recording now. I'm going to answer the last question that's put in the chat, and then we'll be good to go.